Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed the basic concepts of derivatives and we have solved first four questions from exercise 13.2. In today's session, we shall discuss the remaining problems from exercise 13.2. Let's move on to the topic. Let's begin with some of the standard derivatives. Here we are going to discuss some formulas and we have to by heart all these formulas. Here d by dx of x power n is equal to n into x power n minus 1. Next is trigonometry functions, that is d by dx of sin x is equal to cos x. Then d by dx of cos x is equal to minus sin x. Next one is d by dx of tan x is equal to sec square x. And d by dx of cosec x is equal to minus cosec x cot x. D by dx of sec x is equal to sec x into tan x, and d by dx of cot x is equal to minus cosec square x. Here when you notice the trigonometric functions starting with the c, here cos x and here cosec x and here cot x. All these their derivatives are starting with a minus sign. Here d by dx of cos x or derivative of cos x is minus sin x. Derivative of cosec x is minus cosec x cot x, and d by dx of cot x is equal to minus cosec square x. Easy to remember. All trigonometric functions starting with the c their derivatives will begin with a negative sign. Next we shall discuss question number 5. For the function f of x is equal to x power 100 by 100 plus x power 99 by 99 plus etc plus x square by 2 plus x plus 1. Prove that f dash 1 is equal to 100 into f dash 0. Here when you check this statement, there is f dash 1 and here it is f dash 0, means f dash is mentioned, means it is a derivative of f of x. So that is f dash x. First of all, we have to find out the derivative of f of x, means f dash x we have to calculate. For that, let's write down the given function that is written. Then d by dx of f of x, that is f dash x. So d by dx of f of x is equal to d by dx of these terms. X power 100 by 100 plus x power 99 by 99 plus etc plus x plus 1. By using algebra of derivatives, let's expand this one. That is d by dx of x power 100 by 100 plus d by dx of x power 99 by 99 plus etc plus d by dx of x by 2 x square by 2 plus d by dx of x plus d by dx of 1. And here we have learned a formula, d by dx of x power n is equal to n into x power n minus 1. This is the first formula we are going to use here. And one more formula we are going to use for this term, that is a dash, the whole a dash is equal to 0. A dash means derivative of a constant. A is a constant. Derivative of a is 0, means derivative of a constant is 0. These are the two formulas we are going to use here. So d by dx of x power 100, denominator is a constant, so let it be the same. Numerator we are going to apply the formula n into x power n minus 1, means 100 into x power 100 minus 1, that is 100 into x power 99. D by dx of f of x is equal to 100 into x power 99 plus here x power 99, when we apply the formula n, that is 99 into x power 99 minus 1. 99 minus 1 is 98. Denominator is same, it's a constant, plus etc plus here 2x x square, derivative of x square is n into x power n minus 1. N means 2 into x power 2 minus 1. 2 minus 1 is 1. So 2 into x power 1, that is 2x. Denominator there is a 2, it is here. Then here d by dx of x. D by dx of x means x power 1. X power 1 means 1 into x power 1 minus 1, that is a derivative. 1 into x power 1 minus 1. 1 minus 1 is 0. So x power 0 is 1. So 1 into 1, 1. So derivative of x is 1. Plus here d by dx of 1, derivative of a constant. We have learned here it is 0. That is what 0 here. Then this 100 can be cancelled. 99 cancelled. 2 cancelled. So finally we will be getting as x power 99 plus x power 98 plus etc plus x plus 1. So this is f dash x, because we need here f dash 1, f dash 0 and all, means f dash x we have to calculate. We have calculated and got the answer like this. Next we have to go for f dash 0. F dash 0 means we have to replace x and put 0 and x is equal to 0. As you know that when x is 0, 0 power 99 plus 0 power 98 plus etc. plus 0 plus 1 means all these x terms will be changing as 0. 0 rise to any quantity, 0 itself. So there is a constant 1, that is the remaining term here. The balance, all the terms will be 0. So we will be getting f dash 0 is equal to 1. Then you have to go for f dash 1, means at x is equal to 1, f dash 1 is equal to, replace x and put 1 power 99 plus 1 power 98 plus etc. plus 1 plus 1. That is 1 plus 1 plus 1 plus etc. plus 1 100 times. So here when you add this one, we will be getting 1 into 100, that is equal to 100. 1 into 100 will be getting is 100. Now let's check this statement. F dash 1 is equal to 100 into f dash 0. So f dash 1 we have got as here 100. F dash 1 we have got as 100, and when you calculate 100 into f dash 0, that means f dash 0 is 1. 100 into 1 is 100. Means it is quite clear f dash 1 is equal to 100 into f dash 0. Hence the result. Move on to question number 6. Find the derivative of x power n plus a into x power n minus 1 plus a square into x power n minus 2 plus etc. plus a power n minus 1 into x plus a power n for some fixed real number a. Means here we are asked to find out the derivative of these terms. X power n plus a into x power n minus 1 plus a square into x power n minus 2 plus etc. plus a power n minus 1 into x plus a power n for fixed real number a. Here let's take the given expression as f of x. F of x is equal to x power n plus a into x power n minus 1 plus a square into x power n minus 2 plus etc. plus a power n minus 1 into x plus a power n. Let's find out its derivative. Means d by dx of f of x is equal to d by dx of these terms, x power n plus a into x power n minus 1 plus a square into x power n minus 2 plus etc. plus a power n minus 1 into x plus a power n. By using the algebra of derivatives, let it expand. So d by dx of x power n plus a is a constant. So a into d by dx of x power n minus 1. And here a square is a constant. Let it be outside. D by dx of x power n minus 2 plus etc. plus here a power n minus 1 is a constant. So a power n minus 1 into d by dx of x plus a power n into d by dx of 1, because here 1 is there. That's why this d by dx of 1 is coming here. Next is by using the formula d by dx of x power n is equal to n into x power n minus 1, we can find out the values of this one, or we can find out the derivatives of this one. So d by dx of x power n, the formula itself, that is n into x power n minus 1, means here n means the power will be 1 less, that's all. Here n is there, so the power of the derivative will be n minus 1. This n will be coming here, that is n into x power n minus 1. Then next is a into, here power is n minus 1, so n minus 1 into x power 1 less, that is n minus 1 minus 1, that is n minus 2. Next is a square into n minus 2 into x power n minus 3, 1 less, n minus 2 minus 1. Here n minus 1 is the power, so n minus 2 minus 1, that is why n minus 3 plus etc. plus a power n minus 1 into d by dx of x. In the previous question we have discussed this one, d by dx of x is 1 plus a power n into d by dx of constant. D by dx of constant is 0. That is f dash x is equal to, only this term will be 0, the remaining terms will be same as it is. So n into x power n minus 1 plus a into n minus 1 into x power n minus 2 plus a square into n minus 2 into x power n minus 3 plus etc. plus a power n minus 1 plus this term only will be 0. So that 0 no need to write. This is f dash x. Next is question number 7. For some constants a and b, find the derivative of first one x minus a into x minus b. This is a formula we have learned in the smaller classes, x minus a into x minus b. So either you can expand or remove the bracket and write it in order form, or else you can directly use the formula f of x is equal to, here I am using directly the formula, that is x square minus of a plus b into x plus ab, means sum into x plus product. So x square minus of a plus b into x plus ab. If you don't know this formula, you can directly expand this one and then rearrange it. That's all. Anyway, you can do it. Either you can use the formula and directly we can write, or else we can remove the bracket and we can bring to this form. The option is yours. Then we are asked to find out the derivative, that is f dash x is equal to d by dx of all the three terms. We have to write x square minus a plus b into x plus ab. Here d by dx of x square, then minus, here a plus b is both are constant, means a plus b also a constant. Constant we can keep it outside, d by dx of x, then d by dx of ab. Then by using the formula, the same formula, x power n, that is n into x power n minus 1, this one we can write d by dx of x square is 2x, means here power is 2, 2 into x power 2 minus 1, x power 2 minus 1 is 1, that is x power 1, x power 1 is x itself, so 2x will be coming, minus here d by dx of x, we have discussed already, d by dx of x is 1, so a plus b into 1, that is a plus b itself, then d by dx of constant, since a and b are constants, their product also a constant, so d by dx of a constant is 0, that's what here, plus 0, that is f dash x is equal to 2x minus a minus b. Let's remove the bracket, this one. So we will be getting the answer as 2x minus a minus b. Then here there are two more questions, that is ax square plus b the whole square and x minus a by x minus b. So these two questions you will be doing it as homework. Next we shall discuss question number 8. Find the derivative of x power n minus a power n by x minus a for some constant a. Here we are asked to find out the derivative of this function. It is quite clear that it is in the form u by v form, means quotient rule we have to apply. Let's take this function as f of x, x power n minus a power n by x minus a. Then by using the quotient rule, let's recall the quotient rule first, that is u by v the whole dash, means derivative of u by v is equal to, first of all we have to write the denominator square, that is v square, then derivative of the numerator into the denominator, means u dash into v minus numerator into derivative of the denominator, that is u v dash. Even if you change the order like v u dash, it's not a problem. So this is the quotient rule. So when you apply the quotient rule here, f dash x is equal to, first of all denominator square, that is x minus a the whole square, then x minus a means the denominator into derivative of the numerator, that is here when you check v into u dash v, that is the form it is written, v means denominator into derivative of the numerator, order is changed, so it is not a problem, minus x power n minus a power n means numerator into derivative of the denominator, that is x minus a. Once again, first of all denominator square we will write, then denominator into derivative of the numerator minus numerator into derivative of the denominator. Then here x minus a into d by dx of x power n, d by dx of x power n minus d by dx of a power n when you use the algebra of derivatives. This is a direct formula, d by dx of x power n, that is n into x power n minus 1, then d by dx of a constant, that is 0, minus x power n minus a power n, that is here first term x power n minus a power n into d by dx of x minus a. By using algebra of derivative, we can say d by dx of x, d by dx of x we have learned it is 1, then d by dx of minus a, that means a constant, d by dx of a constant is 0. So here 1 minus 0 will be coming, this entire term, 1 minus 0 is 1, when you multiply with this quantity, the same term will be coming, that is x power n minus a power n. Then little bit of calculation is there, expansion of bracket, that is here when you multiply n into x power n minus 1 into x, these two terms when you multiply n into x power n minus 1 into x, then again minus here x into 0, that is 0, then when you come the next term a into n into x power n minus 1, that is what, a n into x power n minus 1, then again a into 0, that is 0, no need to write, then you have to come this side, we have to remove the bracket, minus x power n, that is minus x power n is written, minus into minus, that is plus, 1 into a power n, that is a power n. That is what the expansion of the numerator. Denominator we can keep as it is. Then little bit of a rearrangement. Here when you go for calculation, n into x power n minus 1, here there is a power 1. So when you add the powers x power n minus 1 and x power 1, when you join together, n minus 1 plus 1, there minus 1 plus 1 will be cancelled, only x power n will be balanced. So n into x power n minus, here there is no other calculation, a n into x power n minus 1 minus x power n plus a power n, no other calculation, only here there is a calculation, that is what it is written. Then when you check here, here there is x power n, here there is x power 1, x power n. So these two terms we can bring together. This is the answer, but even we can modify this one. That's what we are going to do. Here x power n, here x power n. We can just bring it together. N into x power n minus x power n. Then this is another term, a n into x power n minus 1. Little bit of modification that we can write as n a into x power n minus 1. Then plus a power n as it is. These two, there is not much changes. These two only we are bringing together. Then in these two there is x power n is common, we can take it out. X power n common taking out means in the first term there is n balance, here nothing is balance, means 1. So n minus 1. So n minus 1 into x power n minus n a into x power n minus 1 plus a power n by x minus a the whole square. So this is the final answer. Move on to question number 9. Find the derivative of first one 2x minus 3 by 4. Here f of x is equal to 2x minus 3 by 4. We have to consider the given function as f of x. Then we have to go for finding the derivative, that is f dash x is equal to d by dx of 2x minus 3 by 4. By using algebra of derivatives, here 2 is a constant. That means d by dx of x. 2 into d by dx of x minus d by dx of 3 by 4. That's what we are going to write. 2 is a constant, just by keeping outside. 2 into d by dx of x minus d by dx of 3 by 4. And here d by dx of x, we know that it is 1. And here d by dx of a constant, that is 0. That is 2 into 1 minus 0. 2 into 1 is 2, 2 minus 0. 2 minus 0 is 2 itself. Next is second part, that is f of x is equal to 5x cube plus 3x minus 1 into x minus 1. And here we have to go for finding the derivative. F dash x is equal to product rule. We have learned the product rule before. So first one into derivative of second plus second one into derivative of first. That is the way we have to write the product rule. First one, that is 5x cube plus 3x minus 1 into derivative of second, that is d by dx of x minus 1, plus second one into derivative of first, that is x minus 1 into d by dx of 5x cube plus 3x minus 1. Then 5x cube plus 3x minus 1 into here d by dx of x minus 1. You can see d by dx of x, algebra of derivatives. D by dx of x is 1 and d by dx of constant, that is 0. So 1 minus 0 is 1. That is what written here. Then x minus 1 into d by dx of 5x cube means 5 into x cube. Derivative of x cube is 3x square. So 5 into 3x square plus d by dx of 3x means 3 into d by dx of x. D by dx of x is 1. So 3 into 1 is 3. Next is d by dx of 1. D by dx of 1 is 0, constant. That means when we expand it or when we do the calculation, 5x cube plus 3x minus 1 means into 1, the same quantity itself, plus here 15x square into x, that is 15x cube. Then 3 into x, that is 3x. Then again 15x square into 1, that is minus 15x square, plus into minus minus, 3 into 1 is 3, removing the bracket. Here just nothing to remove because only 1 is there, the same terms it is there, and here we have to remove with x minus 1. Then we will go for final calculation, that is here 5x cube and here 15x cube. When you add together 20x cube will be coming. Next is x square term, here there is minus 15x square term. Then next we have to search for x term, that is here 3x and here plus 3x, that is 6x. Then there is constant terms, minus 1 minus 3, that is minus 4. So 20x cube minus 15x square plus 6x minus 4. There are 3 more questions, that is x power minus 3 into 5 plus 3x, x power 5 into 3 minus 6, x power minus 9, x power minus 4 into 3 minus 4 into x power minus 5. So these 3 questions you will try it as homework. Next We shall discuss the sixth question. 2 by x plus 1 minus x square by 3x minus 1, that is a given function. Let it be f of x. Let's take it f dash x, derivative of f of x, that is equal to, right side there are two terms. We can just take separately d by dx of 2 by x plus 1 minus d by dx of x square by 3x minus 1. It is in the form u by v. So we have to apply the quotient rule. Quotient rule is u by v the whole dash is equal to u dash v minus uv dash by v square. Means first of all we have to go for denominator square, by that is x plus 1 the whole square. Then x plus 1 into means denominator into the derivative of the numerator, that is x plus 1 into d by dx of 2 minus numerator into, that is 2 into d by dx of the denominator, that is d by dx of x plus 1, minus here also the same thing, denominator square, that is 3x minus 1 the whole square, then denominator into the derivative of the numerator, that is 3x minus 1 into d by dx of x square, minus numerator into, that is x square into derivative of the denominator, that is d by dx of 3x minus 1. Then we'll go for calculation, that is x plus 1 into d by dx of a constant, that is 0. Here algebra of derivatives, when we use d by dx of x, that is 1, then d by dx of 1 is a constant, that is 0. D by dx of 1 is 0. So 1 plus 0 is 1. So 2 into 1 will be coming here, 2 into 1 minus here 3x minus 1 into d by dx of x square. D by dx of x square is 2x, that is x n into x power n minus 1 formula. By using that we can write d by dx of x square is 2x. So 3x minus 1 into 2x minus here x square is outside, d by dx of 3x minus 1, d by dx of 3x. Here 3 is a constant. Then again d by dx of x will be coming. D by dx of x is 1. So here we'll be getting as 3 minus 0. Here d by dx of 1 is 0. So 3 minus 0 is 3. So here will be coming as x square into 3. If you are doing it mentally, it will be easy and you can save the time also. If you feel it difficult, you can go for calculation. It's not a problem. Once again, here x square into d by dx of 3x is 3. Minus d by dx of 1 is 0. So 3 minus 0 is 3. That's what here 3 came. Then here when you do the calculation, into 0, first term into 0, that means completely the term is 0. X plus 1 into 0 is 0. Here only minus 2 is balanced. 2 into 1 is minus 2. So minus 2 by x plus 1 the whole square minus here when you remove the bracket 3x into 2x, that is 6x square. Then minus 1 into 2x, that is minus 2x. Then here 3 into x square is 3x square. Then denominator is same. Then minus 2 by x plus 1 the whole square minus denominator is 3x minus 1 the whole square as it is. Here 6x square minus 3x square like terms. 6 minus 3 is 3. So we'll be getting as 3x square. Here there is only minus 2x balance. We can write it. Then minus 2 by x plus 1 the whole square minus, in these two there is x is common. We can take it x out. Then balance is here 3x minus 2. So x into 3x minus 2 by 3x minus 1 the whole square. Next we shall discuss question number 10. Find the derivative of cos x from first principle. You are asked to find out the derivative of this cos x. Let it be f of x. F of x is equal to cos x. Then by using first principle we can write f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h. That means here limit h tends to 0 f of x plus h. X can be replaced and put x plus h. That is cos x plus h minus f of x is cos x. So cos x plus h minus cos x by h. Here cos a plus b form, cos a cos b minus sin a sin b. By using that formula we can expand this one. Cos a cos b, that is cos x cos h minus sin a sin b. That means sin x sin h. Minus this cos x is written here divided by h. Then this minus cos x we can bring to the first so that we can do little arrangement. Limit h tends to 0. This minus cos x I have written first. Then the remaining term as it is cos x cos h minus sin x sin h by h. And in these two there is a minus cos x we can take outside. Limit h tends to 0 minus cos x if I take outside. First term there is 1 balance. Minus here there is plus, so minus is outside, so one more minus is there inside. Minus into minus plus, So that minus into cos h is the remaining term. Minus this is as it is sin x sin h. Then denominator what we have done is for these two terms we have made a denominator h, and for this term another denominator h, means we split the denominator for these two terms. Okay, that is what we have done. Means if you take the common denominator or common LCM as h, we will be getting the same term. That is here minus cos x we can take out. Then limit h tends to 0, 1 minus cos h by h will be coming here, because this is the formula we can use. And minus here sin x we can take out, and limit h tends to 0, sin h by h. This is also a formula format. That is minus cos x into limit h tends to 0, 1 minus cos h by h, we can write it as 0. Then minus sin x into limit h tends to 0, sin h divided by h. This value is 1. We have learned in the formula. So this is 0 and this is 1. So minus cos x into 0 minus sin x into 1. So the formulas we have written here, this is the formula we have used. Then the first term completely will be 0. Minus cos x into 0 is 0. Then minus sin x into 1 is minus sin x. So derivative of x, the derivative of cos x, that is we will be getting as minus sin x. Next we shall discuss question number 11. Find the derivative of the following functions. First one, sin x into cos x. Here we are asked to find out the derivative only. We can use any format, any formula, it's not a problem. First principle, the method is not mentioned. So here we are going to use the formula. That is, let it be f of x. That is, f of x is equal to sin x cos x. Then this is clearly in the form uv, means product rule we have to apply. So let it be first one u and second one as v. So u is equal to sin x and v is equal to cos x. Since u is equal to sin x, anyway we need its derivative. That means u dash. Means derivative of sin x, we have learned the formula, that is cos x. U dash is equal to cos x. And next we have taken v as cos x, means its derivative also we need. It means v dash is derivative of cos x, d by dx of cos x, that is minus sin x. So v dash is minus sin x. Then f of x is equal to, as we have assumed before, it is u into v format. F dash x is equal to uv the whole dash, product rule. That is equal to u dash v plus v dash u, means derivative of first into second plus derivative of second into first. As I said before, order if you change, it's not a problem. As per your convenience you can write, no problem. So derivative of first, that is u dash, is cos x into v second one, that is cos x. Then again v dash means derivative of second, that is minus sin x, into u first one, that is sin x, that is cos x into cos x plus minus sin x into sin x. Even from here directly also you can write this step, it's not a problem, but just for practice purpose we have used this many steps. As per your convenience you can just follow. That is here cos x into cos x, that is cos square x, and here plus into minus minus, sin x into sin x is sin square x. We have learned a formula, cos 2x formula, that is cos square x minus sin square x is cos 2x. This is the formula we have learned in trigonometry. By using that formula we can write as cos 2x. That is f dash x is equal to cos 2x we have got. Next we shall discuss the second question, sec x. Derivative of sec x we are asked to calculate. We already learned the formula of derivative of sec x, but here we will calculate the derivative of sec x by using the formula. That is f of x is equal to sec x we have assumed. We know the reciprocal of sec x, that is sec x is 1 by cos x. This is in u by v form. Let's substitute 1 as u and cos x as v, that is let u is equal to 1 and v is equal to cos x. As before, let's find out its derivative, that is u dash derivative of 1 is equal to 0, v dash, that is derivative of cos x, is equal to minus sin x. Then f of x is equal to u by v, then f dash x is equal to derivative of u by v, that is u by v the whole dash. By applying the quotient rule we can write, quotient rule we have learned, that is denominator square, then denominator into the derivative of numerator minus numerator into the derivative of the denominator, that is u dash v minus v dash u by v square. that is u dash. We know that it is, we have already calculated 0 into v is the denominator. The denominator is cos x. Then minus v dash. V dash we have already calculated, that is minus sin x into u is 1, divided by the denominator square, that is cos square x. That is 0 into cos x, that is 0, minus into minus plus, sin x into 1 is sin x by cos square x. Then 0 plus sin x is sin x divided by cos square x. Then we can split this one, sin x by cos x into 1 by cos x. This cos square x we are splitting into cos x into cos x. Sin x by cos x we can make it as one group into 1 by cos x as another group. As we know, sin x by cos x we have tan x. 1 by cos x we know that it is sec x. So tan x into sec x. This is the derivative of sec x. Therefore, f dash x is equal to tan x into sec x. Next we shall discuss question number 3, that is 5 sec x plus 4 cos x. Here sum of two terms are given to us. We are asked to find out its derivative. We can use the formula. Let it be f of x is equal to 5 sec x plus 4 cos x. And f dash x we can calculate, f dash x is equal to 5 sec x plus 4 cos x the whole dash. Here dash we are using for derivative, or else we can write dy by dx, it's not a problem. Here I am using dash, instead of dash we can use dy by dx. So here f dash x is equal to this one we have written. By using the algebra of derivatives, we can write it as 5 sec x the whole dash plus 4 cos x the whole dash. Means 5 into derivative of sec x. As we know that derivative of sec x is sec x into tan x, plus 4 into derivative of cos x. Derivative of cos x is minus sin x. That is 4 into minus sin x. And when you remove the bracket and when you go for a rearrangement, it is 5 sec x tan x plus into minus, that is minus 4 sin x. So 5 sec x tan x minus 4 sin x. That is the answer for question number 3. Then move on to the fourth question, that is cosec x. Cosec x also we have the direct formula, but here we are not going to use the direct formula. We will calculate the derivative by using different method. That is f of x is equal to cosec x. We know that cosec x we can write it as the reciprocal form, that is 1 by sin x. F of x is equal to 1 by sin x we have written. Then this is u by v format. As before, let's substitute the numerator as u and the denominator as v. And as we know that u is 1, its derivative is 0. V is sin x and its derivative is cos x. Derivative of sin x is cos x. Then f dash x is equal to, the derivative of f of x is f dash x. F dash x is equal to u by v the whole dash. Quotient rule we have to apply, that is denominator square we have written. Then u dash v minus v dash u in the numerator. So let's substitute it. U dash we know that it is 0 into v is sin x minus v dash is cos x into u, that is 1. So 0 into sin x minus cos x into 1 divided by sin square x we have substituted. Then 0 into sin x we know that it is 0, cos x into 1, that is cos x divided by sin square x, that is equal to cos x divided, 0 minus cos x, that is minus cos x by sin square x. We will split this one as before. Here minus cos x by sin x we will take in one group, and the remaining there is one sin x that will be separated, that is 1 by sin x. So as we know that cos x by sin x, that is cot x. So minus cot x, 1 by sin x we know that cosec x. So the derivative of cosec x we have got as minus cot x into cosec x. So we will write f dash x is equal to minus cosec x into cot x. Next we shall discuss the fifth question, 3 cot x plus 5 cosec x. Let it be f of x. F of x is equal to 3 cot x plus 5 cosec x. And here we are asked to calculate its derivative. F dash x is equal to 3 cot x plus 5 cosec x the whole dash. By using algebra of derivatives, we can write it as 3 into derivative of cot x plus 5 into derivative of cosec x. And we have learned the formula of derivative cot x and derivative cosec x. Derivative cot x is minus cosec square x. and the derivative of cosec x is minus cosec x cot x. So we have to substitute that one. Derivative cot x, when we substitute, minus cosec square x. So minus will be coming first, minus, here there is a 3, minus 3 cosec square x, and here cosec x derivative is cosec x cot x. So when you substitute here minus cosec x cot x, that minus will be coming here, minus 5 also is there, 5 into cosec x cot x. Sixth question, there is f of x is equal to 5 sin x minus 6 cos x plus 7. And seventh question, f of x is equal to 2 tan x minus 7 sec x. And these two questions you will be trying it as homework. Dear students, today we have discussed question number 5 to 11 from exercise 13.2. I request all the students to by heart the given formulae and solve the given questions in a sheet of paper independently. While solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.